We're going to work on problem 10 now in module 3. In this particular problem, we're doing a hypothesis test, but a very specific kind of hypothesis test, a very different one, called a chi-squared test. Chi-squared test or hypothesis test on categorical data. So in this problem, we're going to look at data that is all categorical. We are running a coffee shop and we're wondering about the preferences of different types of coffee drinks depending upon gender. And so I collect data and I get 60 observations, and during that observation I collect a gender variable and a coffee drink type. There's coffee, there's cappuccino, there's lattes, there's soy-based drinks, and then male and female. I want to create a table, contingency table, based upon this information. So I do a lot of sorting. I create a sort on the basis of gender and drink type, and I organize all the females who drank cappuccino, all the males that drank, all the females that drank coffee, latte, soy-based drinks, etc. And I count them. I count up the observations. For example, there are 18 males that drank coffee. The result is a table that organizes this data, a contingency table. It says of the 32 males that were sampled, 18 drank coffee, 8 drank latte, etc. And for females, here are the numbers. So the question is there a tendency for males to prefer one type of drink versus another? So does gender matter when a coffee drink is being selected? It looks like males drink a lot of coffee. Females seem to have a more balanced view of the world, some coffee, latte, cappuccino, etc. So there may be a gender, underlying gender relationship with the coffee drink. This is a contingency table. I take this table, and the first thing I do is I calculate an expected value table. The null hypothesis of this test is that there is no difference, that there is no relationship between the variables. It doesn't matter what type of gender you have, given your selection of coffee types. So there's no relationship. The alternative is that there is. So let's see if there is. If we find variations here in what we expect, here's what we expect based upon these marginal numbers in terms of proportions. We'd expect if there was no difference, 13.3 of the males would have selected coffee, 3.2 would have selected soy-based drinks. Notice that there was 0, and there were a lot fewer. There were a lot more coffee drinks, 18 versus 13.33. So we're starting to see a tendency for an influence of gender on the drink selected. So here are our expected value tables. Then we're going to take these expected values and we're going to calculate a variance between the expected value and what we actually got. That's what we do in this table. We calculate chi-squared values. We take the difference between this cell and this cell. We square the difference and we divide by C45, which is the column total. And so we get these chi-squared values, and if that sum of all these chi-squared values is large, here's the summation of all of that, then we can reject the null hypothesis that they are independent in favor of that they are dependent upon one another. So what's a large enough chi-square value? Well, it's all relative to the magnitude of these numbers here, but an easier way to do this is to calculate a p-value. And this is what we've done right here. This p-value is calculated using the chi-test function, and I believe now it's also the chi-dot-test function. Yes, Oh, nope, it's the chi-test function. Chi-test right here. So this is the function that we want, and this chi-test looks at the table, the contingency table up above, and the expected values. This is the actual range of contingency table. Here are the expected values. We can see these here and here. And it does that calculation of the chi-square and works its magic and then gives you a p-value. Notice the p-value that we've gotten. Sorry, let me change that. Notice the p-value that we've gotten here is 0.013591. This is a smaller value than 0.05, so our rule holds as it did before in hypothesis testing. If we get a p-value that is smaller than the alpha value, then we can reject a null hypothesis that the variables are independent of one another in favor that there is a dependency. Males prefer more coffee, and females have a more balanced view of the world in terms of their coffee drinks. So here's our answer. We reject the null hypothesis that they're independent in favor of dependency because this value is smaller than 0.05. That's the end of problem 10 in module 3.